Hello programmers, Dan McElroy here with a discussion on how to read and write random access files while simulating an automatic teller machine. This project simulates an embedded automatic teller machine system as opposed to a typical user application on a computer. Back to the organization chart for the Java ATM project. Let's start out with Java ATM.java. It has public static void main, open parentheses, etc., close parentheses, and this is where the program execution starts. I'll give an overview of the rest of the sections as I work through the sample of customer transactions. The description of the code for the Java ATM project has a lot of detailed information. Don't worry too much about trying to understand it all for your first viewing. If your brain starts to feel like it is being overloaded, it is time to pause and take a rest. Go back and review what you have already seen, then progress and try to absorb a little more. It is important that you understand as much as you can of the program because the lab portion of the final is based on this program. The first thing I see is that the package statement on line 1 has been commented out because I'm looking at the code using online GDB. Then come the declarations for a bunch of constants. The names of the two data files are located here and are outside the curly braces for the module subroutine definitions. This makes them visible in all of the modules within the class. If you don't put the data files in the same project location as I did, you can specify the exact path name and file name in the constant declaration. These are used in several places in the code. It makes it much easier to define the file names in one location, and then if you update the program, you only need to change the constant declaration instead of searching through the entire program to make sure that you updated everywhere it is used. Then are some more declarations of constants. I'm using these to define the characters used for the various transaction selections. Additional constants are used to define the return codes for the method subroutines. I named the scanner object keyboard. At this point in the program, keyboard is only a reference that will hold a scanner object when it gets instantiated by the new operator. It can't be used until it is instantiated, but at least it is declared outside of any of the methods, including main, so that it can be seen and used anywhere within the Java source file. It does not need to be named keyboard. I have seen it named stdin, kbd, or other names. You just need to use the name that was defined when it is needed later in the program. Execution of the program starts at public static void main. The customer index is used to keep track of where the selected customer's data is located on the disk file. The another request variable is used to hold the Y or N response when asking the user for more transactions for the current customer. The Boolean welcome message flag is initially set to true so that the program only displays "Greeting, John, how can we help you?" message one time where John is the actual customer's name. Once the message has been displayed, the flag is set to false so that this message does not repeat for more transactions. When a new customer is selected, the flag is set true again to welcome a new customer by name. The customer name class definition starts with an uppercase C and is in the customer name.java file. Customer name equal new customer name, open close parentheses, semicolon. Instantiates the customer name object, which starts with a lowercase c. The instantiation or object creation is done using the new operator. This is where keyboard becomes an executable object when it is instantiated using new scanner open parentheses system.in close parentheses semicolon. Now it can be used to input data from the keyboard. Be careful with the statement while open parentheses true. This creates an endless loop, but it is very common with embedded systems. An embedded system usually has software that never stops working unless power is lost or there is some fatal error that causes it to stop. There are a few cases within this program that will cause the program to end, such as entering Q to end, or if an error is encountered when trying to open one of the data files or trying to read from it. The search for customer open close parentheses method is called, which we will see asks for the customer account number and PIN and then searches the customer.txt file for a match. A do while loop is formed to process multiple transactions for the same customer. If a match is found, the method returns the file pointer of where the customer data is located. The user can enter a Q to quit the program or F to display the customer database instead of entering a customer number. The search for customer open close parentheses method can return several other codes besides the file pointer, Q or F, such as codes for the account number not found, bad PIN, or non-numeric data entered. The return code is tested using if and else if statements and appropriate action taken to either exit the program using the return statement, skip processing the transaction by jumping to the end of the loop with a continue statement, or if everything is good, doing two things. One, display the personalized welcome message, and 2, executing the code in the process transaction method. We are now reaching the end of public static void main. Inside the do while loop, the user is prompted with the message, another transaction for the same customer, YN. The do while loop keeps repeating until the user enters a Y or an N, or at least something that starts with Y or N, since we're only looking at the first character using char at open parentheses 0 close parentheses. Actually, YES or YUP or yada yada all satisfy the Y condition, and nope, nah, etc. satisfy the N condition. The next while curly brace closes off the while true loop. The final close curly brace is for the end of public static void main. One thing I would like you to notice is the comments on these curly braces. The comments are sure helpful if it is not totally obvious what they are for. Even if you are the only one writing the code and don't expect anyone else to look at it, it may have been clear when you first wrote the code, but what about 2 weeks later or longer? Be kind to yourself and others by providing good comments. The search for customer open close parentheses method returns a long integer data type that can give the location of the file pointer back to the main program if the customer record is found. Since an int or long is big enough to hold a character, the return code can also be used to hold a Q or an F or other character codes when a customer record is not found. Customer record equal new customer record, open parentheses, close parentheses, semicolon. Instantiate a customer record object, starts with a lowercase c, from the customer record class definition, starts with an uppercase C. If a customer is found, the object will hold all the information about a customer, including checking and savings balances. A prompt message asks the user to enter F or Q or an account number. The keyboard input .to uppercase open close parentheses char at open parentheses 0 close parentheses reads the keyboard and returns the first character converted to an uppercase letter. Inside the try block, I'm checking to see an F was entered and then displaying the customer records.txt file. There are some other conditions the code is looking for, but I'm skipping over these during the discussion. You can check them out if you wish. Integer.parseInt open parentheses keyboard input close parentheses. Integer is a method of the .int data type that has several methods available for working with integers. Other data types such as character, double, etc. also have methods for working with those data types. The integer.parseInt open close parentheses method receives a keyboard input as a string data type and then converts them into binary integers. Since the account number is entered at the keyboard as a string of characters, the parse int open close parentheses method is used to convert it into an integer. The customer accounts.txt file name was previously defined as a constant in accounts_file at the top of the program. Random access file open parentheses accounts_file, comma, quote r, quote, close parentheses, semicolon, opens the file for reading. The new operator creates an object for the file and places it in the accounts file object, which can be used inside the curly braces for search for customer method. String line creates a variable named line of type string that will be used when reading a line of text from the customer accounts.txt file. The get file pointer gets the file pointer FP at the location of the current record before it has been read from the disk. Then we read a line from the disk which will have a customer record. If the result of the read is a null string, indicated by two double quotes with nothing in them, since we have not read anything from the disk, we must have reached the end of the file. Remember how the customer record object was instantiated at the top of the method. Now we can use it. The customer record.setAccountInfo, open parentheses, line, close parentheses, method receives a line of text and will parse it into an integer account number, an integer PIN, a double checking balance, and a double savings balance. We will see how this is done when looking at the class definition in the customer record.java file. The customer record class has methods for retrieving each of the numeric values for account number, PIN, and balances. These methods are referred to as getters. There are also methods for setting values into a customer record object. These are referred to as setters. We're going to be looking for a match between the account number entered at the keyboard and the account number that was read from the disk. If, open parentheses, account number equal customer record.getAccount, open close parentheses, is using the double equal to compare the account number from the keyboard to the get account number that was read from the disk. If they match, then we do the same thing for the PIN. If, open parentheses, PIN equal customer record.getPIN, open close parentheses, is using double equal to compare the PIN from the keyboard to the get PIN that was read from the disk. If both the account number and PIN match from the keyboard and the current disk record, the break statement exits the loop and the customer index is returned back to the main program. The customer index is the FP in the file for the current customer. If a match is not found using the current record from the disk, we stay in the loop and read another record from the disk. If we reach the end of file without finding a match, the customer index is set to no_ACCT for no account, and the main program can process this return code as described above. I'm skipping over some code here that processes several error conditions. You can look over the code yourself if interested. The display file open close parentheses method in Java ATM is not very complicated. It first displays a header identifying names of each column of data. It opens the customer accounts.txt file and starts a do-while loop that reads a line from the file and displays it until the end of file is reached. Catch blocks catch any errors, display an error message, and return the error code back to the main program. The display file method displays the contents of the customer accounts.txt. You could just as easily see the same information by opening the customer accounts.txt tab in the IDE's editor. It is provided here in case you don't have access to the file in the IDE or to simulate the ability of a bank customer representative to access the data files. The display file method in Java ATM is not very complicated. It first outputs a header identifying the names of each column of data. It opens the customer accounts.txt file and starts a do-while loop that reads a line from the file and displays until the end of file is reached. Catch blocks catch any errors and display an error message and return the error code back to the program. Process transaction method displays a menu for the user to select a balance inquiry, deposit, or withdrawal. Once a menu item has been selected, control is passed to another method to do the actual work. The process transaction method is also very simple. It first displays a menu with options for balance inquiry, deposit, withdrawal, and cancel. A do-while loop reads the options selected from the keyboard and stays in the loop until a valid entry is made. If B is entered, which is defined by the balance constant at the top of the file, the display balances method is called and the loop is exited using the break statement. Likewise, if a D or W is entered, the appropriate deposit or withdrawal method is called. The select account method displays a menu and lets the user select their checking or savings account. The select account method is probably one of the simplest of them all. It displays a menu with options for selecting checking, savings, or cancel. The keyboard is read and the do-while loop program stays in the loop until C, S, or X is entered. The selection, as a character data type, is then returned to the main program. The display balances method displays the selected customer checking and savings balances. The display balances, open parentheses, long, customer index, close parentheses, method is not very complicated. A customer record object is instantiated and used to get the customer record identified by customer index. The customer accounts.txt file is opened using random access file, open parentheses, accounts underscore file, comma, quote, R, quote, close parentheses. The file pointer, FP, is moved to the customer record identified by the customer index using accounts_file.seek, open parentheses, customer index, close parentheses, semicolon. A line of text is read from the file using accounts_file.readline, which is passed to the account info method belonging to customer record, which parses the 4 fields into 2 ints and 2 double data types for account number, PIN, checking, and savings balances. The printf statements are used to display the balances to the screen and the file is closed. The withdraw method processes a withdrawal request from either checking or savings account and updates the new balances to the disk file. The withdraw method is a little more complicated. The withdraw method starts by opening the customer accounts.txt file, seeking to the selected customer, and retrieving and displaying the selected account balances. Before completing the transaction, it needs to get the withdrawal request from the keyboard, make sure that there are sufficient funds in the account, make sure the withdrawal request is a positive number, limit the withdrawal to $500, and make sure the withdrawal request is an even multiple of $20. The check for sufficient funds needs to be completed as part of the lab assignment. After all conditions for the withdrawal are satisfied, the new balance is computed and set to the customer record object that is in RAM. A seek command is issued to move the file pointer, FP, to the current customer's record on disk. The updated customer data is written back to the disk and the file is closed. The updated balance is displayed on the screen. The code for deposit method needs to be written by each student as part of the lab assignment. The code for the deposit method is something you need to write for your lab project. Since it does not have any actual code in the method, I used a red dashed line around the project diagram. The withdrawal method is to request the amount to deposit, then validate that the amount is greater than 0. Deposits are not limited to increments of $20. However, deposits need to be rejected if the resulting balance would exceed $1 million. 1. Read the customer record from the disk. 2. Select either checking or savings. 3. Display current balance. 4. Input the deposit request. 5. Verify that it is positive and would not cause a balance greater than $1 million. 6. Update the customer balance and display it. 7. Write the customer record back to disk. The deposit method in its current form is just a stub function, meaning that it has the method declaration, static int deposit, open parentheses, long, customer index, close parentheses, and it only has a return statement inside the curly braces. The Java ATM program will run with just the stub, but won't process a deposit. Probably the easiest thing to do is review the code in the withdrawal method and how it is constructed. Determine what you can use and what needs changed. Make sure that you verify that everything is working correctly. Have fun. GetInt and getDouble methods are helper methods that can be used by the main program. The last things in the Java ATM code file are the getInt and getDouble methods. The getInt method just reads the keyboard, expecting a positive integer to be entered. If successful, the text string is read from the keyboard and converted into an integer data type and returned back to the main program. If something other than an integer is entered, an error message is displayed. The code loops back to give the user the opportunity to enter a positive integer. Code for the getDouble method is not shown here. You can see it if you want by looking at the Java ATM Java file. When an object is instantiated for the customer record class, it can be used to hold data for one customer. The actual code starts out with public class customer record extends Java ATM open curly brace. The keyword extends indicates that this is going to be an inherited subclass of Java ATM. A customer record class can then have access to any of the non-private data or methods defined in Java ATM. The customer record class declares 5 variables to hold data from a single customer record, but also hold the file pointer for the customer record on the disk if that customer is located on the disk. The customer record, open close parentheses, is the default constructor that is executed anytime customer record object is instantiated or created from the customer record class definition. Since all variables declared above have private access, no other code can get to them. The setter and getter methods have public access and provide a way for the main program to access the private data. For example, set index, open parentheses, long, index, close parentheses, receives the file pointer from the main program as an argument named index inside the parentheses. It then saves the file pointer into customer records private variable named index. Since both the name of the private data and the variable passed inside the parentheses are named index, there needs to be a way to distinguish between the two. This references the current object so that this .index refers to the data that is inside the customer record. The variable index without the this dot refers to the data that is being passed to the method from within the parentheses. So this .index equal index semicolon copies the data from main passed to the method within the parentheses into the private data that belongs to the customer record. The same data goes back to main through the return statement just in case main wanted to use it in an expression. Even though I never used the data provided by the return statement in this project, it is good practice to provide that opportunity. The other setters work similar to setIndex. The getters are similar to the setters except that they only get data from the customer record object and pass it back to main without making any changes to the data. Each Java class has a toString open parentheses close parentheses method automatically built into an object. Anytime the main part of the program references the object where a string is expected, the toString method is called. For example, system.out.println customer record would give the information about the customer record object. However, I have coded my own version of toString for the customer record class because I want it to do something different. Since I have my own version of toString, I need to preface it with the @override operator. Now, if main does something with a customer record where a string is expected, my version of toString will be called instead of the one Java has built in for the object. My version of toString returns a string formatted the exact same way as a record in the customer accounts.txt file. They both need to be exactly the same because when an ATM transaction is completed, the new customer data needs to be overwritten on the disk in the same format as the original data. The set account info open parentheses string customer data close parentheses method receives a text string that was read from the customer accounts.txt file. The text string is parsed into separate tokens. Each token by default is separated by one or more spaces. In English, this means that a customer record such as 6114878 space 1781 spaces 1006.40 spaces 3507.27 would be separated into 4 separate tokens. The first token is 6114878. The second token is 1781, and so on. The tokenizer.nextToken, open close parentheses, gets these tokens one at a time. Integer.parseInt tokenizer next token, open close parentheses, gets a token as a string of characters and converts them into an integer numeric data. The assignment operator equal then stores the numeric data into the private variable shown at the top of the class definition. The account number and PIN are treated as integer data types because they don't have digits past the decimal. The checking and savings balances need to be treated as double data types because they do have digits past the decimal. When an object is instantiated for the customer name class, it can be used to hold data for a customer's account number, first and last name. The customer name.java class starts out similar to the customer account class, but with variables declared for account number, first name, and last name. Setters and getters are provided in a similar manner to those in the customer account class. The search for customer method is provided in customer name.java class. Search for customer, open parentheses long, customer index, close parentheses, receives the index position in the customer accounts.txt file for the current customer. We need the customer's account number, which can be found in the customer accounts.txt file. The search for customer, open parentheses, long customer index, close parentheses method, opens the customer accounts.txt file and seeks to the position for the current customer and retrieves the account number from the file. Now that we have the customer's account number, we can open the customer names.txt file and search for the same account number in that file. When it is found, the data is retrieved from the customer names.txt file for the current customer. The getter methods can be used in main to get the customer's first name and then build the personalized welcome message that is displayed when a new customer is selected in main. The personalized message displayed in main would be, "Greetings, Jose," where Jose is the customer's actual first name. A lot of information has been provided in this presentation. A simulated automatic teller machine, building a multi-file project that accesses 2 data files, working with random access files, searching a data file, parsing a string of text, converting text into integer and double data types. Credit for the ATM image goes to http://depositphotos.com/stock-photos. See you next time. Dandolph, signing off for now.